This is Dr. B. This is your lecture on topic 4.5, stoichiometry. So yes, moles, molar mass, all the type of stuff. So the objective for today is explain the changes in the amounts of reactants and products based on the balanced equation reaction for a chemical process. So we're going to have to do stoic, know what's a chemical process, be able to write out be able to determine and also balance a chemical equation, and use an equation to get percent yield. Actual mass obtained divided by calculated mass times 100%. So stoichiometry, is used to describe conversions that involve mole ratios from a balanced chemical equation. You must make sure you have your chemical equation balanced. If not, you're going to have issues. So make sure you know what is being asked and read the question carefully, knowing what you're given or you're known, or determining what it is you're looking for, your unknown. Make sure you use the mole to mole ratio correctly in order to convert from one thing to another. You may be asked to determine the limiting reagent, or what is the excess reagent, etc. So the limiting reagent or reactant is the one that runs out first, and the excess one is the one that's not completely consumed. It's the leftover one after the limiting one is used up. You use percent yield because sometimes you may not get what you're supposed to get. So you may get an actual yield from the actual experiment versus what you're supposed to get theoretically. And this is just the thing we can use. Percent yield equals actual yield over theoretical yield times 100. Actual is what you actually got, and theoretical is a calculator or what you're supposed to get based on the stoich. How many grams of water can be produced by decomposing 1.0 grams of hydrogen peroxide, according to the equation below? So 1.0 grams of H2O2, converting that to my unknown, which is grams of H2O. So 1 mole of H2O2 on top, grams of H2O2 on the bottom. 1.008 times 2 plus 16 times 2. My molar mass is 34.016. Now my mole to mole ratio. So 2 moles of H2O2, converting that to 2 moles of H2O. And then 1 mole of H2O on the bottom, grams of H2O on the top. So 1.008 times 2 plus 16, so approximately 18.016. This will equal my grams of water. So multiply your numerators, 1 times 2 times 18.016. Oops. Just to be thorough. So you have 36.032. Your denominator is 34.016 times 2. Oops, 68.032. Divide those two numbers, you end up with 0.529 something, 2 sig figs, so 0.53 grams of water. Limiting reagent example, you have your reaction between iron and oxygen forming rust. If you were to react 15 grams of iron with 6.5 liters of O2 at STP, how many grams of rust would form? So we need to treat each reactant separately and then compare to find the limiting reagent and therefore the theoretical yield of rust. Start with a balanced equation. So they give it to you, luckily for us. So both of these, I need to convert them to the same thing. So for example, 15 grams of iron, let's just convert that to moles of iron. 1 mole of iron on top, 55.85 grams of iron on the bottom. So that's my moles of iron. So 15 divided by 55.85 is 0.268 moles of iron. So I'm going to take my 6.5 liters. It tells us that my O2 gas is at STP. So in 1 liter, I have 22. No, sorry, I had it backwards. In There, that makes more sense. In 1 mole of O2, I have 22.4 liters of O2. I'll convert this over to iron based on my equation. 3 moles of O2 on the bottom, 4 moles of iron on top. 6.5 times 4, so I have 26 on top. 22.4 times 3 on the bottom. 26 divided by 67.2. I have 0.38. Whatever moles. This means my iron is technically my limiting reactant or limiting reagent. So I need to convert that. So I'm going to use this up here to convert over to grams of rust. Okay? So I'm going to erase the bottom because I need space. Use a different color. So I have approximately 0.26857, let's find moles of iron. In 4 moles of iron, I have 2 moles of Fe2O3, 1 mole of rust on the bottom. Oops, that's ugly, my bad. On the top will be grams of the grams of iron 3 oxide. 58 or 55.85 times 2 plus 3 times 16, 159.7 for that. So the 0.26857 times 2 times 159.7 divided by 4 would give me 21.44. So then my final answer is going to be 21 grams of Fe2. Why do I keep on doing that? Fe2O3. What is the percent yield in the reaction? Oh, Jesus. So now, if you notice, we don't have a balanced equation. We are given 2 reactants, so that means we need to figure out what is a limiting reactant, and from there get the theoretical yield, and then from there get the percent yield. So cesium by itself, it is cesium like that. There's no, if it's a metal and you're creating the reaction, the balanced reaction, it's just by itself if it's a metal, like aluminum, sodium, etc. Oxygen, it is here, it's stated oxygen, but it implies that it's molecular oxygen, so O2, and it tells us that, luckily it tells us that cesium oxide is CS2O. Balance. Four, 1, 2. So, yeah, that's cool. So I got to convert both of my reactants to figure out what's the limiting one. I'll convert both of these to cesium. Moles of cesium, so, oh Jesus, 132.91 about. Grams of O2, convert this to 1 mole of O2, which is 32 grams of O2. Convert that over from 1 mole of O2 to 4 moles of CS. 46 point 132 point, what is wrong with me today? Don't answer that, whoever's listening. 0.3468 something moles. 13.4 times 4, and then that's 53.6 divided by 32 is actually 1.675 moles of cesium. So that means my cesium is actually my limiting reactant. So yeah, it makes sense because 40, 60 divided by a bigger number, 132. Okay, so then now that means that my molar mass, my limiting reactant was cesium. Converting that over to cesium oxide, so I'll do 0.3468 moles of cesium. 4 moles of cesium on the bottom for my mole to mole, 2 moles of CS2O. My molar mass, 1 mole of CS2. I think I had too much coffee today. CS2O. On the top, it's going to be the molar mass. So 132.91 times 2 plus 16, 281.82 grams of CS2O. 0.3468 times 2 times 281.82 divided by 4 would give me a mass of 48.86-ish grams of CS2O. So you'll notice right here, I determined my theoretical yield by doing the stoich. In the question, it says if 28.38 grams are collected. Right here, this is my actual yield. So to get my percent yield, I need to divide. I'm just going to copy the sig fig. So my percent yield is 28.3 grams divided by 48.9 grams from the problem, or from my answer, my stoich, times 100. 28.3 divided by 48.9 times 100 is 57.9%. My percent yield. I only got 57.9% of what it is I'm trying to get. That was a lot, I know.